That covers series. Let's look at parallel now, in parallel. Now, as you can see here, these resistors are in parallel. Now, if they're in parallel, this is the formula you use to work out the resistors. All you look at is 1 divided by R, where R is the total effective resistance. So that's the total, equals 1 divided by R1, which is the resistance of resistor 1, plus 1 divided by R2, which is resistor 2, plus 1 divided by R3, resistor 3, and it keeps going, depending on how many resistors are. So this is the formula to work out the effective resistance of resistors in parallel, okay, in parallel. Let's do an example. Determine the effective resistance of this circuit here. So this is a circuit here. Right, what is the total resistance of the circuit? Well, putting known values in this formula here, as you can see, 1 divided by I equals 1 divided by 4 plus 1 divided by 4 plus 1 divided by 2. Well, that's a quarter plus a half, it's 1. This gives us a value of 1 divided by R is 1. Gives us a total resistance of 1 ohm. So the effective resistance of this circuit is 1 ohm. So, how does the current flow in this type of circuit? Well, the total current flowing in the circuit is divided by each branch. If you've got 3 branches and they've got the same resistance, you'll get a third flowing in each one. And it depends. The whole circuit will have the whole flow, but if it's equally balanced, if you had 4 in parallel, 4, and the resistance was exactly the same in all 4, well, all you'd happen is you'd get a quarter in each. That's how it works. You get a quarter in each. Again, the best way to look at this is the analogy of water flowing in a large pipe that suddenly is divided into 3 smaller pipes. Well, it's the same principle. Okay, so how much current will be flowing in this circuit? Well, we know the total voltage is 6 volts. And the total resistance of all a lot of them is 1 ohm. Therefore, the current is 6 amps. So what you do is you work out the effective resistance and use the same formula. It's 6 amps. So 6 amps is flowing in that circuit. Well, how much current is flowing through the first resistor? Well, look at the formula here, I equals V divided by R. If you put that in, I equals 6, we know the voltage, divided by the first resistor's 4. We've got 1.5 amps flowing through that first resistor. You see, 1.5 amps. How much current's flowing in the second resistor? Well, as the resistance is the same as the first one, the current's the same, 1.5 amps. Well, now you could work out the next one. You could say, if I know if there's 6 in the circuit, if there's 1.5 there, there's 1.5 there, it will be 3. But let's work it out. I equals V divided by R. I equals 6 divided by 2 gives us 3 amps flowing. Do you understand? You could work it out if you know the other 2, but therefore in the whole circuit there's 6 amps. However, in the first resistor there's 3, then 1.5, then 1.5. That's how you work it out when it's in parallel. That's how you work it out.